Hello everyone. I'm going to walk you through my process of making a diamond sword from the Minecraft game. My daughter is a very big fan of the game, and for her birthday, I thought it would make an ideal gift. So I set about to kind of create my concept of what that would be. So I set out to simulate as best I could how it appears in the game. And so I started out with a steel plate. I'm going to make the sword out of steel plate, and I drew it in ViaCAD. ViaCAD is a CAD program. I specifically use ViaCAD to draw DXF drawings. That's a drawing exchange format, very common drawing program, very useful in CNC plasma tables. I'm going to cut this out on a CNC plasma table. So you draw it in ViaCAD. Won't go through the whole process, but it's pretty simple. Drawing a series of lines using reference grids. Once that's done, you can export the drawing into SheetCam. And SheetCam is very commonly used for CNC tables, specifically plasma tables. And SheetCam sets in, the lead out, the edge offset, also known as a kerf width, the pierce height, the pierce delay, the cutting height, all these different parameters, the cutting speed, direction of torch travel, all the parameters used to create a part out of a flat sheet of plate. After SheetCam post processes that, I bring it out on a USB drive, plug it into my Masso control that I have on my CNC table, which I built myself. And really simple design. There's a lot of people online that have there's a zillion types of DIY CNC plasma table choices out there. I just kind of went my own way, kind of pieced it together with what I had at the time. But you can see here the master controller has the cut profile, imports all the information from SheetCam, and then it'll go straight into XY0. I set that, and then I load it and start cutting. So here's the cutting process on my table. You can see the table actually touches off. You can see that little red switch on my Z-axis. It actually goes down to it actuates that switch and then retracts. And that's an auto height sensing feature the lathe, or the CNC table has. And so at each pierce, it goes down and touches off. There's an ohmic sensor you can use too. And I have used that on this table, but I found this the switch touch off to be extremely reliable, so I just went with that. But you can see here, it's moving along. I have a water tray underneath. It catches almost all of the dust and debris and smoke. Plasma cutting is a very dirty operation. It produces a lot of smog. So I use a water table, catch all the smoke and dust and debris. Works pretty well, and it cools the part too, so you don't get a lot of heat deformation from the steel heating up. It's a very hot process. The part drops right out into the water tray and cools off the part. When it hits, it goes in that, kind of quenches. It can edge harden along the cut edge once it drops into the water. I found that to be the case. There's a very hard oxide layer on the perimeter edge, but I'm not going to be doing any machining operations. I'm just going to be grinding this and polishing it. And so there's the finish. Almost no dross. Tells me my speed and cut height were almost perfect. Here I am running through some flap discs. I think I started out with a 60 grit flap disc and moved to an 80, and I think my final was 100, I think. And I'm going to be putting a heat coloration on this blade, so polishing it actually really brings out a lot of the colors. Really helps a very vibrant color. And so I had to do a mild polish on this so that I could get the color range I was looking for. Blues, golds, and purples is what we'll see. I marked out these. These are going to be cut in with a Makita grinder, one of my favorite grinders. I'm going to use a cutoff wheel to actually cut the shape of these lines in. So I laid them all out with just a Sharpie and a straight edge. And I will use a .045 width cutoff wheel. And I'm just going to be scoring the surface just to create this diamond pattern that you see here. And so it's all laid out. I laid out both sides and basically followed the interior little vertices from the profile, made that marks, made them all interconnect, and it's already starting to look like a diamond sword. Yeah, there you go. So here I am cutting out each one of these lines with my Makita grinder. And I have several of these grinders. Sometimes I'll have 3 of them hooked up at once. One will have a cutoff wheel, one of them a flap disc, one of them will have a wire wheel. It's just so much easier to switch between the grinders rather than swap out each different blade for each different operation. So sometimes I'll have like 3 or 4 of these things hooked up on and hanging. I'll grab each one at a time. They're fairly inexpensive. They last a long time. I don't think I've ever had one fail on me. So they have bearings in them, are really high quality. They last a long time. I just never had a problem with them. So this profile here could have been cut out. I could have cut it out on a CNC machine. I could have got a V-groove cutter and clamped the blade down and had this pattern cut in. But sometimes I just, for small operations, something simple like this, especially that's decorative, sometimes I just prefer to cut it by hand. Let me know what you guys think on that. But sometimes I just prefer just using a hand tool. And this cutting actually came out, these lines came out really straight. You wouldn't think the tool's unsupported. I'm just holding it by hand, but it definitely, once you get a certain type of depth, it was very easy to get these. These are very straight cut lines, and the depth was easily controlled. The pattern came out just about perfect. Just make sure you wear eye protection, ear protection on this. You can wear shorts though, but pants are optional. Eyes and ears protection, that's non-negotiable. So here I am using the oxygen acetylene torch to heat the steel to these certain colors. You can hear my daughter and I talking in the background over this, but this is quite a lengthy topic to go into. Probably don't have the time to discuss it here, but heating the steel actually induces a chemical reaction. It produces an oxide layer, but the interaction of oxygen and the surface of the steel actually falls under the realm of chemistry. As the steel heats through certain ranges, the oxide layer grows, and then depending on the height of the oxide layer, it alters the incidence of refraction of the light that is bouncing off the surface. And depending on the oxide layer, it will actually filter out and discriminate certain light composition. So obviously, light is hitting it. It will filter out all the other colors, and then it basically reflects a certain wavelength. And so you see that color depending on the oxide layer. This oxide layer is induced by a temperature. Typically, I think it starts around 300 degrees as a light straw. 350 to 400 is like a straw to a gold color. Then it can move to a purple and a blue.
Propane's easier.
And there's a whole range. This range of colors actually exists between 300 degrees and 700 degrees, I think is the range. And you can very easily go past if you heat it too much, and then the oxide layer returns to a gray color and you've pretty much lost your color. And so it's very easy. This is a very sensitive process. You have to heat it. You see me in the video intermittently quenching it. Here's the final product. And so you can see I've gotten some blues, I've gotten some golds, I've gotten some purples. It's got quite a little bit of a translucent effect here. Really looks like the video game. This came out just near identical to some of the iridescent effect you see in the game. So this is a little bit lower light condition, but you can see how vibrant these colors are. These are just incredible. And that's kind of a byproduct of the polish that I put on it and the type of steel too. Uh, Certain alloys actually show vibrant colors depending on rather than just plain steel, but this is a chrome only steel that I polished. These colors just came out just incredible. But you see I'm moving on here to a paracord wrap. And I'm using a 550 cord as it's known. It's very common in use in the military. There's a lot of knockoff brands too that aren't exactly 550 cord. The 550 cord is a reference to its breaking strength. Paracord or 550 cord breaks at exactly 550 pounds of force. So for its size, it's very strong, has a lot of good properties, doesn't absorb very much moisture, is very salt resistant. Paracord, as the name implies, is used in the manufacture of parachutes and lots of different things in uh, aviation survival equipment. So it's very, for its size, it's very durable and very dependable cord. I fast forwarded through some of this. It's just alternating weave pattern into that groove cut in the handle. Very simple. There's lots of different other paracord wraps you can do. Um, and there are some knockoff cords you can get. You can buy at Home Depot, you can buy at Walmart. Amazon carries actual 550 cord and the knockoff stuff, and it's all pretty good. Once again, this handle is just kind of something that's comfortable to use. It's got a good aesthetic. So, uh, and I'll get some close-ups of the wrap, but it's just an alternating braid that goes through that center groove that was cut in on a plasma operation. Once I'm done here, uh, I do a final turnaround and then I do an overhand knot. Then I trim these off and then I sear them. Just use a lighter. Here you can see some shots of the finished handle and finished wrap. And you can see some of my where I seared the cord. It's a little overzealous on the lighter on the end there, but that kind of I melt that end, it locks it in, and it's very durable. It's not going to come out. So you can see the finished pattern, all the grooves that were cut in, the heat coloration. This is it, and my daughter freaked out when I gave this to her on her birthday. She was just really amazed. All right, guys, I really appreciate your time on this, and thank you. Good luck.